Hello everyone. Today we are going to discuss about electric dipole. Till now we have seen an isolated charge or a line charge distribution or surface charge distribution or the volume charge distribution. In the same way there is an electric dipole. Uh, Today we are going to discuss about that. So what is an electric dipole? A two-pointed, so dipole in the sense, in the name itself you can able to see it's a dipole. It means that two point charges which is having the equal magnitude but with a different sign. Okay, so the two charges which will be having the equal magnitude, the value of the charges will be same, so but the sign will be opposite. So one charge will be having the plus sign and the other charge will be the negative charge and the positive charge. And when these charges are separated by a very small distance, it will give rise to an electric dipole. So generally the field produced by such a dipole, it plays a very important role in the engineering electromagnetics. Okay. So let us see how a dipole will be looking like. So let me draw the figure. So I'm just taking three axes in the rectangular coordinate system. As you know, it will be x, y and z. So suppose here there are two charges which is lying here and a charge exactly here. So where so this could be a negative charge and this could be a positive charge, plus. Okay, so plus and minus. Okay, right. So just a minute. So let me draw this again. So I will be having three coordinates. So I am taking here a Cartesian system, which is also called as a rectangular coordinate system. So which is having x, comma y, comma z, and I will be taking one positive charge in the same way, so one negative charge. Here if you see the charge which is negative, so that is lying on the z-axis, the negative z-axis. Okay, so this is the dotted line which I am showing you. So it is a negative z-axis. Okay, so now if you see these two charges are lying on the z-axis, which is exactly 90 degrees to the x and y plane. Okay, so here these two charges are separated by a distance of d. They are separated by a distance of d. Okay, so now if I take any point P, consider a point P. I am taking this in the spherical coordinate system. Okay, so which is having r, theta and phi. Okay, so let me consider a point P and I am representing this in the spherical coordinate system. Okay, so if you see this charge Q is lying at a distance of charge Q is lying at a distance. Okay, this is the line, so this is lying at a distance of r1. Okay, so in the similar way the charge q2, sorry, which is the minus q, so that is the other charge. Okay, so rather than saying q1 and q2, I will be saying so positive charge and the negative charge, because both the charges are having the equal values with opposite sign. Okay, so this charges, let it be placed at a distance of r1 and r2. Okay, so generally if you are taking a sphere, you know that this is a dot, and I will be just drawing why I am taking as a sphere, because In the cylindrical coordinate systems, whenever we are taking any point P, so mostly on the surface, so if you draw a complete circle, it means that the point P is lying on the surface of a sphere. Okay, now it is required to find the electric field intensity E bar, so due to that electric dipole at the point P. Okay, so now I have taken this point P, so that I want to find out the electric field intensity E bar. Okay, so the electric field intensity E bar at the point so P. Okay, so before finding the electric field intensity, to find the expression, we need to take the absolute potentials. Okay, so as there are two charges, positive charge and the negative charge, so I'll be taking two absolute potentials. One is the V1 and other one is V2. Okay, so V1 is the absolute potential due to the charge Q, so other one is due to the charge minus Q. Okay, so as we know that absolute potential can be written as Q by 4 pi epsilon naught R1. Okay, so in the same way here also we can take minus Q. Okay, so because I am taking the absolute potential V2 for the charge minus Q. Okay, so this is 4 pi epsilon naught R2, because this charge minus Q is at a distance of R2 with respect to the P, and in the same way, so this charge plus Q, positive charge, is lying at a distance of R1. Okay, so now what I am going to do is, now if you have only one charge, the potential can be due to any one charge, either it can be due to the positive charge or either it can be due to the negative charge. But here the total potential is taken as V1 and V2, which is a combination of both the charges, because here it is, the charge is not a single charge, it is not a single pole, it is a dipole, because we are taking the combination of the charges plus Q and minus Q, where they are having the different polarities. Okay, so dipolarities. Okay, so now the absolute potential is due to the combination of both the charges. Okay, so hence absolute potential, the total absolute potential can be given as V1 plus V2, which is equal to, so I am going to add these two equations, so finally you will be getting, so Q by 4 pi epsilon, and remember, so epsilon naught I am taking because I am assuming that the medium is air. Okay, so otherwise you can able to take epsilon, so which is equal to epsilon naught into epsilon naught. Okay, so epsilon naught represents the permittivity due to the free space or vacuum. So finally I will be writing as 1 by R1 minus 1 by R2. So this will become Q by 4 pi epsilon, okay, R2 minus R1 by R1 R2. Okay, so this is the total absolute potential V. Okay, so this is the total absolute potential V, which is given by Q by 4 pi epsilon. If you see here, there is only one charge. Okay, so this charge Q is not because of the one single charge, it is because of the two charges, which we say as the dipole. Okay, so now this dipole is nothing but whenever we are having two charges, di in the sense two. Okay, so two charges, but the polarity is different, so plus Q and minus Q, which are separated by a distance of d. Okay, so then it will be forming a dipole. Now if you observe this, taking the dotted, this is the dipole. But what I have done here, due to this dipole, I have calculated the absolute potential V. Okay, so at the point P. Now this point P is located on the surface of the sphere. Okay, now if you assume that this charge, okay, so this dipole plus Q and minus Q, so we have found the absolute potential at the point P. Now let us assume that the point P is at infinite distance. Okay, the point P is at infinite distance, and also let us assume that the point P, okay, so the point P which is at infinite distance, okay, so which means that the R1 and R2, they are not the fixed values, they are the infinite values. Okay, So let me take same axis again. So this is x, this is y, and this is z. Okay, now the charges are, so this is the positive charge in the same way, so this is the negative charge, okay, which is exactly lying on the minus z axis. Okay, now if you observe, when it is at infinite distance, so it can be assumed as a parallel lines. Okay, it can be assumed as a parallel lines, something like this, because the point P is at infinite distance. Okay, so, and if you take this point from the origin also, the distance of P is somewhere, we don't know where it is, but it is at infinite distance. Okay, so let it be this R1, the same way this is R2. Okay, so this distance from the origin is R. Okay, so now what I am going to do is, I am drawing is a perpendicular line here. Okay, so this perpendicular line, okay, so this dotted line is exactly perpendicular to the R2. Now what I can able to assume this is, when the point P is at infinite distance, okay, so if you remove this small distance, now we can assume, or we can able to say that this R1 is exactly equal to R2, because P is at infinite distance. Okay, so exactly the, as if you are taking the parallel lines. Okay, so as I am drawing this perpendicular distance, if you are calculating from here, so now R1 can be said as it is equal to the R2. In the same way, it is equal to the R. Okay, now if you see, the R1 distance is measured from the positive charge Q. Okay, in the same way, R2 is measured from the minus Q. Okay, but what is the difference between R1 and R2? If you clearly observe, R1 or R2, I am taking R2 minus R1 is equal to some x. Okay, so but what is R2 minus, as I am saying that R1 and R2 is same, but it is same from these points. Okay, so but the difference between the R1 and R2 is this distance. Okay, and this distance is, let it be x. Okay, and let this angle making with the vertical line to this R2, let it be some theta. Okay, so let it be some theta. Now as we know that this distance is d, okay, as we know that this distance is d, then according to this plus q minus q and this point, okay, so let it be some point C. Okay, so they will form a triangle. Okay, so now can we able to measure the distance of x? Now I want to find out the distance of, okay, if you see, okay, I am taking this, the triangle outside. Okay, I am taking this triangle out. This is 90 degrees here, and this is theta. Now I am going to find out what is x here. Okay, so just here I am taking the same triangle out of the diagram. So this is plus q, this is minus q, and this is origin, and the distance between the plus q and minus q is the distance t. Now what is this x? If you see this is a triangle. Okay, and if you know this plus q and minus q, the distance between the charges as d, and if this angle theta, the finally then x will become, I just want you all to just think and just write down this equation. So just to take a time of 1 minute, just think. Okay, so just think and write down what is x, because you can able to take this triangle, and using trigonometry you can able to find out what is x, and this x distance, x will give the difference between R2 and R1. So take a time of 60 seconds. I am giving a time of 60 seconds. Try to think and reflect and try to write down what is x, because whenever you are studying, so EMF, So the basic mathematical fundamentals is very very important, because everywhere you need to use the mathematics. So this is as simple as d cos theta. You can able to write as a d cos theta. Okay, so this x value can be given as a d sin theta, because if you see this is a triangle, so this could be a d cos theta, and even if you want to find out this could be a d sin theta. Okay, so now r2 minus r1. Okay, so here if you see, this is r1 and this is r2, and the point P is located at the infinite distance. Okay, so when r1 and r2 are equal, which are measured from these points, but there is a difference between r1 and r2, because r2 is not starting from this point C, but it is starting from the point the place where the minus q, the charge minus the negative charge is kept. Okay, so if you remove this distance x, then we can able to say that r1 and r2 is same. Okay, so the difference between the r2 and r1 is x. Now from this triangle we can able to get to know that, so that x value is nothing but the d cos theta. Okay, so now what I am going to do is, so this v, so v is equal to q by 4 pi epsilon naught d cos theta by r square. So how I got this equation? Because in the earlier slide, if you see, so the v is equal to q by 4 pi epsilon naught r2 minus r1 by r1 r2. Okay, so now as the point P is located at infinite distance, r1 is equal to r2 is equal to r. Okay, so that we have, so r1 is equal to r2 is equal to r. So the denominator r1 r2, what I can able to do, so that this denominator r1 and r2 I can able to simply write it as, so this r1 and r2 I will be simply writing as r square. Okay, and if you see in the numerator, so this numerator, so r2 minus r1, so that's what we have found as d cos theta. Hence if you see in this equation, so v is equal to q by 4 pi epsilon naught into d cos theta, the numerator, which is r2 minus r1, so divided by the r square. Okay, so this is what the absolute potential when the point P is located at the infinite distance. So what is our main intention? Our main intention is to find out the electric field intensity E bar. Okay, so how we can able to find out the electric field intensity from the absolute potential? So as we already seen, so electric field intensity can be given as the minus gradient of V. So as in the earlier lecture we have seen, the electric field intensity can be given as the gradient of the voltage. Okay, so now we know that gradient, it can be written as, so dou by dou r into AR bar. Okay, so as we have seen this earlier, so if it is in a spherical coordinate system, so the del operator, it can be written something like this: rho theta a theta plus 1 by r sin theta dou by dou phi a phi. Okay, so this is minus, and if you see this is a V is a scalar which I am writing directly here. Okay, so this is the del, the representation of how you are writing the del operator. Okay, but if you observe, I am writing this in spherical coordinate system. That's the reason why you are seeing AR, A theta and A phi, because the point P which we have taken earlier where we are finding the absolute potential, okay, so to find out the electric field intensity is taken in the spherical coordinate systems. So that's why the del operator I have represented in the spherical coordinate systems. So this is the equation for the del operator. So it is dou by dou r into AR, where AR, A theta and A phi, they are the unit vectors. Okay, so now how can we multiply the voltage V with this del operator? Is directly you can able to multiply directly whenever you are multiplying a scalar with any vector or with any del operator kind of thing, you can able to directly multiply. So suppose if you see here, so I am directly multiplying this voltage dou by dou r V AR bar plus 1 by r dou by dou theta V, again I am writing V, so A theta plus 1 by r sin theta dou by dou phi V into A phi. And this del operator, actually we have seen in the previous classes, this del operator, so dou by dou r AR plus 1 by r dou by dou theta A theta plus 1 by r sin theta dou by dou phi A phi. So this we have already seen earlier how to represent this del operator for all the coordinate systems, whether it is a rectangular coordinate system, whether it is a spherical, or whether it is a cylindrical coordinate system. Okay, so now what we need to do is, here if you see, so this part, so dou V by dou phi A phi. So before going to this, already we got the absolute potential, so we need to replace that absolute potential in this equation. Okay, so what we can able to do is, first of all I am taking this value, dou V by dou r. If I am finding dou V by dou r, then you can able to get this equation. Okay, so in the same way I will be going to find out what is dou V by dou theta. Okay, so if you are finding this, then you can able to get this equation. In the same way, dou V by dou phi, dou V by dou phi. So if you are finding all these three, so obviously you can able to find out the entire equation. Okay, then we will be getting the electric field intensity area. Okay, so how to find out dou V by dou r? Already we know that V, we know that the absolute potential V, it is given by Q by 4 pi epsilon naught d cos theta by r square. Already we got this equation. Okay, now what you need to do is substitute this equation 1 in this, and finally in this. Then you will be getting one certain equation. Then you need to replace in this equation. Okay, so when you are doing the partial derivative for this absolute potential with respect to dou r, so you will be getting the equation like 2q d cos theta. Okay, so you will be getting something like this, 2q d cos theta by 4 pi epsilon naught r cube. In the same way, dou V by dou theta, so you will be getting, so after doing the partial derivative you will be getting, so dou q d by 4 pi epsilon r square into minus sin theta. But if you observe here, when you are taking dou V by dou theta, so in this voltage equation you can't find any phi value. So obviously when you are doing this dou v by dou phi, as there is no phi value, so this will become 0. Okay, so because here if you see in the dou v by dou r, already we have the value of r here. Okay, so then we can able to do the dou v by dou r. In the same way, dou v by dou theta is also existing because we have the cos theta value. But dou v by dou phi, if you clearly observe, there is no value of phi. So whenever you are taking dou v by dou phi, as there is no phi value, then obviously you will be getting 0 for this. Okay, so finally what you need to do, so you need to substitute all these three in the equations. Okay, so you need to substitute the first one here. Okay, and you need to substitute this one here. Okay, and in the same way, this 0, whatever you got is 0, so it will be taking this position. Okay, so after substituting finally, so you will be getting the electric field intensity as E bar is equal to, so this is the final equation I am writing. So before that you need to do 1 or 2 steps where you can able to substitute all those values which you got in through dou v by dou r, so dou v by dou theta, so dou v by dou phi. Okay, so finally, so this is the final result which you will be getting. So 4 pi epsilon naught r cube 2 cos theta ar plus sin theta a phi, sorry a theta. And if you observe, this is the final equation, and you can't able to find the a phi because a phi already we got 0. Okay, you can able to get this unit vector ar and a theta, because whenever you are taking this, see here, so this dou v by dou r, dou v by dou theta, you are getting some specific values because you are doing the partial derivatives for the absolute potential. But when you are seeing the third one, you don't have any phi parameter, hence you will be getting the 0. Okay. So in the final equation, you can't able to observe the unit vector a phi. Okay. So now what you have done is, you have found the electric field intensity due to the dipole. Okay, so whatever may be the charge here q which you are seeing, so it is not a single charge, but it is, you got this charge based upon the dipole. Okay, so it is effect of not a single charge but effect of both the charges which are separated by a distance d. Okay, so this is the electric field intensity which you have obtained for the dipole moment when the point P is located at infinite distance. So after this, we can able to see a dipole moment. And also the torque on electric dipole in our next class.